All right, I have retried. Someone said that's working in Twitch. Oh, that's interesting. Oh, it's buffering in Twitch. Okay. And is it live? You hear me? Yes. YouTube's working now. Okay, I'm stepping in front of this camera because I know this one's working. Yeah, sorry about that. We got a bunch of different gremlins going on. You got a signal. You can see me now. Can you see me from this camera? I opened up a little separate app, photo booth, to try. That video is going to be super laggy just because of how I'm having to pipe it from a screen capture. So tell me now, I'll hang out for a second, if I jump in front of this camera, how is the lag, how is the audio sync, and if it's working pretty well, I will at least try to use this camera as much as I can. So that is the question. Let me know in the chat if you are able to see the this main workbench camera. Yeah, very laggy on the second camera. Hey, bummer. That's weird. What is, let me see, what is YouTube saying? YouTube, yeah, they don't love my bitrate. A frame a second, that is awful. All right, we're gonna do a little full restart. Oh wait, now some people are saying good audio, good video. All right, so where is it good and where is it bad? Dexter Starboard, are you watching on Twitch? The YouTube chatters are now saying it's working. Okay, yeah, it's also just my delay in getting answers from you. Main cam is good. Okay, this camera's perfect. Okay, thank you. So I'm gonna try again to make a real FaceTime camera work over here instead of this thing. So let's do a new video capture. Wow, that's so weird. It is always grabbing the wrong camera there. So I'm gonna quit and restart this whole application. So please stand by. Hey, check this out. My camera's back. Let's see if that gets picked up. The stream is starting up. YouTube says it is a miserable bitrate. I shake my fist at it. That's no good. Yeah, I'm back, but it's not a super great frame rate, so we'll see. Or bitrate, I should say. We'll see. But I've got a camera, so I'm happy about that. So here's what we're going to do. I'm going to fix now a couple of my screen captures because those never survive a restart. What is this one? Adam. Okay. This one is Discord. Hello, Gene Fiend. Hello, Roy. Thanks, everyone. Let's see. What is this? This is going to be Google Chrome and live broadcast chat. Let's see. This one is looking good. How about that? That's looking good. Okay. Cameras. That's a camera. That's a camera. That's a camera. All right. Here we are. Hey, everybody. Welcome to John Park's workshop. This is it. This is John Park's workshop. Having some issues today with our stream. Very sorry to say. So one thing that was going on in the chat earlier, and I didn't realize you guys couldn't hear me, is that C. Grover had found a transformer in his attic, I think, for ringing an old doorbell. And I think he said it was from 1941, which is great because I actually pulled off of the wall here original doorbell from this house, which was built in 1938. And I'm going to send you this doorbell if you want it. It's a nice doorbell, and it's a 16 volt, uses a 16 volt transformer. It's a new tone from Cincinnati, Ohio. So tell me, C. Grover, if that'll work, because I want to send that to you and get you back in touch with your roots as far as reliable doorbell technology. All right, let's see. Miserable bit rate's better than no bit rate. This is true, and I'm glad this camera's working. So, some things. I'll skip jobs other than to say head to the jobs board to check out jobs.adafruit.com. There's a position here that has not yet been filled, as far as I know, for a contract job to build a submarine-themed office's control panel, including buttons for macro controls over video, rotating lights, warning lights and siren, fog machine, LED, fluid pump, optional triggers for Zapier. So pretty cool. C. Grover says he was going to send me the transformer. Well, then we'll still not have the full set. Maybe it was never meant to be. What else? Let's jump into, how about a CircuitPython parsec while the stream seems to be working. Sure, here we go. All right, let's get set up here. I just want to make one little change. That ought to do it. And I'm going to open up a different file. Here we go. So what I wanted to show today in, let me get that set up there. What I wanted to show today for the CircuitPython parsec is a really simple command that you can use to check how much memory is being used on your board when you are doing things, when you're importing things, when you're importing libraries, when you're using big files. How much memory have you got left? This is a really simple command you can use. It comes from the garbage collector library. And here's how you can use it in real time. So what I'm going to do is go into the REPL for this Pico that I have sitting right here. And now I'm going to just go and hit Control-C, which brings me directly to the REPL after going into screen. And I'm going to import GC, which is the garbage collector. Now, the garbage collector has a bunch of different things you can do with it, but what I'm going to use is this mem-free. So if I do a let's say print GC mem-free, it will tell me I have about 210K, 2,576. If I then import a library, so I'm going to import another library. Let's do import USB HID library. Then I can run this print command again, or just GC mem-free will work. And you'll see now my available memory has decreased because we've added another library in. So as you can see by the code I have up above, you can sprinkle this through some code while you're debugging it and working on it, so you can have it do things, maybe bring in a library, check the available memory, and use it as a way of figuring out where you're running out of space in case that's something that's happening to you. And so that's how you can use the garbage collector to check the available memory on your board inside of CircuitPython. And that is your CircuitPython parsec. And I should also add, of course, there are other things you can do like garbage collection, which allows you to free up space, essentially, get rid of unused things. So you can use the gc.collect to sort of get rid of space that's being used that shouldn't be, that you're not asking for. There's also ways to delete libraries out of memory and then check it again. So you can see some of the code up there. I was testing out some different commands. So check out Garbage Collector. It's pretty useful if you are deep in it with a board and right on the edges of your memory usage. This might be a helpful technique. All right, so jumping backwards in my usual order a little bit, I want to mention that I have a show on Tuesdays that's called JP's Product Pick of the Week. It usually looks something like that. And this week's was this 1.69-inch rounded rectangle display. And what I'll do is I give a product recommendation, product pick, show you a demo, talk about how it works, and there's always a really big discount available during the show. We actually broadcast this show from inside the product page, and there's no coupon codes or anything needed. You don't have to solve any riddles. You just simply buy it while the show is happening. It happens on 4 o'clock Eastern Time, 4 o'clock p.m. Eastern Time on Tuesdays. This week's product pick was 50% off. Here's a little 1-minute recap. It is the 1.69-inch round rectangle display. This is a TFT display, and it has 240 by 280 pixels, and it's a nice tight resolution, 220 pixels per inch. Look, that guy likes rounded corners. We have a couple of ways of hooking this up. You can use the pins here at the bottom, or we've got this little ribbon cable connector, this flex cable connector. And so there will be some upcoming dev boards that will allow us to really nicely and neatly plug that little ribbon connector in. I'm inspired by this to want to mount that on my wrist and make a little miniature baby version of the PipBoy. If you were to mount some 3D printed or laser cut electronics around it, you would include a sort of rounded radiused corner there. And it's built into the display as well. You can see the pixels don't go all the way to the edge. The round rectangle display. It is the 1.69-inch.
Hey, watch out, buddy. Yeah, that thing was just in looping mode. Sorry about that.
So that little display actually got inspired during the show to try to build it into a project, a full-blown project, which is what we're going to do today, what we're going to look at project-wise. So let's get into it. First thing I'll do is I want to talk about PipBoys in general, because what's a PipBoy, you may ask. Let's open up a little browser here, and we will search for PipBoy. And if we just go to an image search, you'll see the PipBoy is a prop from inside of the Fallout games, Fallout series of games. Full disclosure, the only one I've ever played is Fallout 4. I know Fallout New Vegas is a big favorite of a lot of people. But you can see here are some examples of PipBoys in the real world in action. I don't know if we'll see any pictures of them in-game, but it is a big wrist-mounted computer type of gizmo. In fact, here's the wiki, fandom wiki for it. So this tells you about the games that it's in, the model numbers of the different PipBoys in those games, the history of them, appearances, how it's changed, its functionality. And so you essentially use it as a menu system to go between things like a map or GPS map to allow you to set waypoints and head places out in this post-apocalyptic world, as well as check on your inventory, check on your health, and so on. So that's the PipBoy, and you even get little cartridges for it in the game that allow you to play back little snippets of important audio and video. This is the concept art, I think, for the 3000, the Model 3000, which was in Fallout 4. And I'll head to Adafruit's Learn Guide and show you a PipBoy that the Ruiz brothers made a few years ago using a Raspberry Pi and a TFT, I think it was a TFT display. So here it is, beautiful cosplay prop. And if we take a look at the 3D printing section of this, you'll see these are the parts that you would print. And some cleanup you do, tapping some screw holes with some screws, and then you build this this circuit up, and they probably have a video here I can attempt to play. Oh, maybe not, or it's on the last page. Have you guys done a video on that? Let me know. There should be a Ruiz Brothers video of this. If we go to the mounting components, last page here, you'll see everything coming together here of power boost and I think there's some amplifier, speaker, battery charging circuit, and on and on. And in the end, you've made this gorgeous looking PipBoy. So
my idea with our rounded rectangle display is, what if we made a sort of miniaturized version of it? These are usually, pretty big, as you can see. So I wanted to make one that's more like a big, humongous wristwatch than it is a full arm band thing. So the rounded rectangle display is kind of the inspiration for that, because even on its own, without building up a model for it to build or to print, we get kind of that 4:3, almost 4:3 ratio look to it with the rounded corners, so it feels like a old-fashioned tube TV kind of look. So, excuse me. You can see also in the original design we have a screen, and then to the right of it we have controls. And so in iterating on this, I came up with this kind of a design. Let me go to a down shooter now, actually, where I have this feather tripler, which allows me to put a feather as well as a joy feather wing, which gives us controls, gives us analog joystick here. So this is essentially 2 potentiometers, as well as 4 buttons. And this uses a seesaw chip, so it's pretty easy to interface with in code. It's more straightforward than if you were asking to read a couple of potentiometers, and instead is all done over I²C. And that's another nice thing about it, is that this feather wing is really only getting power ground and the I²C lines from the feather that's underneath, which means we don't have to worry about using up pins that we need to run the display, because our display, as you can see there, it has a lot of connectors. We don't actually use all of these, but we do use about 5 of them for the SPI screen connection there, which is a lot faster than I²C would be. So this is kind of the general design. I've also started, it's my second iteration of getting it down onto a board. I made some mistakes with the first one, and I bailed on it. I wanted to keep the size down as far as the height of it, the sort of depth on your wrist. And so you can see here I'm going to go over some sort of steps that I'm taking. We'll see if they pan out in the end. But one of them is I've soldered the, sorry about the focus there, come back. I've soldered the feather almost directly to the board. So what I've used here, I'm going to clip these, but right now for testing these are good to have. I've used some of our extra long header pins. They have sort of the full, 5 millimeters or so on either side of the plastic spacer. I moved that up into place from underneath. I soldered the feather to the top of those pins. I then removed the plastic spacer. It takes a little bit of work with sort of a little spudger and some pliers to pull off all of the, let me grab a typical, here's a typical one. This is a short one, actually. So removing all of those allowed me to get that space down real low, but still have enough height here to plug in header pin on top. I may go with the sort of shallower header pins here. These are these short feather headers that may work out well. But right now with this height, this gives me a way to connect the display at essentially the same height as that board there, which I kind of like. I might get this down lower and then build up the 3D printed case so that the screen is a little higher and the joystick and buttons are maybe recessed a little bit from there. So one of the things I did, so I had actually built a version of this on a breadboard, and that's the one I showed on the show the other day, and that was with a Metro and the display just plugged in over here, like so. When I went to this design, I made the mistake of not trying it on a breadboard first, so that's when I got some things wrong, including the board I was trying to use didn't have enough memory. This is kind of why I got into this garbage collection thing. Didn't have enough memory to load the images, so I switched it out for, and that may be something I can solve. It was a Feather NRF 52840 Feather Sense, which should have enough memory, so it could be something else going on. with the image load library on it. I'm not sure. But for now, at least so we had something working today, I've put in a Feather RP2040. And I kind of like the name PipBoy RP2040, so why not? One of the ideas behind using the Feather Sense was that it has some sensors on there for humidity and temperature and light, and accelerometer, which means it would be a fun one to do wrist things with and maybe pretend, there was a suggestion Lamore made, maybe pretend the humidity value or the temperature value is really a Geiger counter so that you can use this essentially as a prop. So my idea is to do this as a prop, kind of like a cosplay prop. I'm not trying to make a watch out of it. I'm not trying to do low power stuff and have a real-time clock on there or anything. So I'm not really trying to make a watch. I'm more making a cool looking wrist accessory. So the other thing that I've done here, and as I write this up as a guide, I'll share some fritzing diagrams of what's going on. But essentially, since I have these headers, this row of pins that I'm using on this display, I wanted to mechanically fasten them to this board, so they're stuck on there. And again, kind of for testing, what I did is I used an extra long stackable header cable so that I could, or a header pin assembly. It's got both pins and sockets, so that I could bend over its leads and solder my connections to it sort of temporarily. Make sure I like where everything is, make sure it all works, which it is now. Then I can go and clip these and solder smaller jumpers directly from the board to some of these shared pins. So the nice thing about these feather wings, these doublers and triplers and quadruplers that we have, is that these pins are all shared. So that pin, what is that on? Let me pull this off here so I can read it. So D4, this pin right here is D4, is D4, is D4. This is the pin 13, pin 13, pin 13. So that means I don't actually have to come around to the bottom side and reach all the way across the board. You can see I've already done it here with power. I'm just running to this power row here, which is the same as that 3 volt. Ground, which is the same as that ground. And then I'll run these just right across the way here to the pins that I'm using, and maybe over to this row here. The other thing that I like about this, and I think I forgot to bring the one I had played around with yesterday here, is that the hole spacing here is pretty good for a watch strap, for a wrist mount. So you might want to do this with something else Velcro if you're going the outside of a space suit, or who knows what, your dweller jumpsuit. But I've got sort of a typical watch band here, nylon watch band, a bit of a thicker watch band, and it'll fit between these holes right here. And so that means I can run a zip tie, pair of zip ties, one whoop there and one whoop there, and that'll hold it really nicely. So we'll do that after we get that assembled, if we want to check that out. Let's see. So let's have a look at functionality. I think you understand the connections, what's going on there, and why I'm doing some of this temporary stuff, which I can then make permanent. It's sort of a step between the breadboarding and the full-blown, here we go. And so then I'll be able to clip those once I solder the shorter connections. So I'm going to plug in my feather wing here as well. And let's give this some, oh, by the way, one other thing is that we've got space under here for a battery. So I was thinking of using one of these 420 milliamp hour LiPos. It'll just live right under there. It'll be connected, and the feathers charge. They have a charging circuit built into them, which means this is going to stay nice and simple and compact, and I won't have to add another board for charging. For now, I'll leave the battery off, and I'll go ahead and plug in USB-C. And let's take a look at what I've got demo-wise right now. So we have a single image coming up. Yesterday, or on Tuesday actually, I showed sort of looping through them as fast as I could. What I'm going to do here, I'm not really trying to animate this unless I rewrite something in Arduino to get it going really, really fast, GIF player kind of thing. But if I'm doing this in CircuitPython, I don't think I'm going to do animation. I'm going to do static screens with maybe some elements that we can control with the joystick and the ability to move between pages. And I think that's kind of one of the key things. In fact, if I open up, I'm going to show you there's an app you can get from Bethesda Software that is the official PipBoy, Fallout PipBoy app. And this is a great way to see what it kind of does in the game without having to get the game. It can be connected to your game, or you can play in offline mode. So in offline mode here, or demo mode, you'll see the screens. So this is your typical how's your status screen. There's an inventory screen, data screen, a map screen, and the radio, which will play back little cartridges you get. So I think I'm going to just do those screens for a sort of simple cosplay prop. And for now, just to test that theory, what I did was I'm reading these two buttons here, which are the B button and the X button, since I have this sort of rotated. And you can see if I press the B button, oh, I have to say, you know what, I got to save some new code on here. I had to rewrite that right before we started. So let's go and look at the code for a second and fix that. I overwrote what was on there by accident before. And let's see, if I open up some code I have saved on my network. Where are you? You are almost here. There it is, code 2. All right. Let me just save it on there. We'll check it works, and then we'll look at how it works. So let's save that as code on the... Hey, where is my CircuitPython drive? What's going on? It's not showing up. If not, it'll be impossible. There he is. CircuitPy drive showed up. I'll save it as code. Replace. Cross fingers. And this should now restart. Did you restart? There it is, restarting. And in this mode, it is now watching for me to press the button. So you can see each time I press this button, it's going to advance a frame. And I'm not going to try to do the world's slowest flipbook animation with it, but instead have those 5 screens. And then if I press the back button here, you'll see it goes back a frame. So we can make him moonwalk. So that's just using these 2 buttons. We have up and down we can use, then we also have the joystick that we could use for something. It might be kind of cool to put a cursor on there or adjust brightness or something. I don't know a lot about the alpha test stuff, alpha blending that Jepler was showing off yesterday, but the ability to blend between, the sort of transparency between 2 images would be pretty cool using alpha channel. So maybe that could be used to adjust that. So that's the basic demo of what I've got going on, and then let's take a look at the code that I've got running on there now. So here is, there we go, better view of that. So here's what I've got going on. This has some libraries that I'm bringing in. The Seesaw library is what I'm using to be able to use the Joy Featherwing. And that's because it has a Seesaw chip on it that interfaces all of the onboard analog reads of the potentiometers inside of the joystick, as well as the 4 buttons. All of that stuff is being sort of buttoned up and sent to the Feather board over I2C. Image load is what I'm using to show those images, and then the driver chip for this this display is this ST7789. Next thing we do is release the display using display.io release displays. And then we set up the I2C channel for using Seesaw, or bus rather, so I2C bus on the boards. I2C pins is being used to set up Seesaw as a thing called SS here. Then setting up the SPI for the display, so it's board SPI. And then there are a couple of chip select pins. I'm using D5 and D6. This is basically out of the demo that Melissa has in her guide on the round rectangle display. And then I'm using pin D9 for the board reset. And we're setting up on the display bus this 4-wire or SPI display using those pins. Then we set up the display using ST7789 on the display bus with a width of 280 and a height of 240. So you can use this as a vertical or a horizontal type of display, or portrait versus landscape. So you change those depending. I actually don't know what the row start is about. It might be the 20 pixels that are missing there in the corner. And then the rotation I had to set to 270. If not, this thing will be upside down or kind of off by 90 degrees. Then I'm using some display.io commands to create a group to hold this content, adding that screen to the display. And then based on that image load code that ToddBot had posted, I've got my little slideshow essentially set up where I'm giving it this list of 8 images, image names, and those are what I have stored on disk, what I have stored on the Feather in memory. Then append the display.io group to the screen, set up the variable names for the buttons, so right down, left, up, select, button mask, and then this Seesaw pin mode bulk is how it reads that mask, that button mask message that comes across over I2C. It's also setting up the Seesaw device as an input pull-up. And then I have some variables here to tell if the joystick has changed. It won't update anything unless they change, so we have a couple variables to hold there. And then the frame, that's essentially the screen, the display screen that I'm picking of my BMP files, which file I'm looking at. So we start off looking at file 0. And then here's what's happening in my main loop. So when I was doing the slideshow, I had this jazz right here. I don't need that anymore. This either, because I'm not pausing. So I'm setting up the image and palette using Adafruit image load, and then the file name is whichever number we're looking at from this list up here. So initially it's this pip01.bmp. And I can show you those files in a minute. Then screen 0 is display.io tile grid, that image that we just loaded, and the pixel shader is that palette. That loads the image up right there. So then all we need to do to change those, again, this is really preliminary code that because of some of my hardware blunders this morning, I just got this code running this morning. So it's not effective or efficient, or I guess it's effective, it gets the job done, but it's not super efficient because it's just constantly trying to redraw that screen. I need to have it only update that when it changes. But I am also always checking the 2 potentiometers inside of the joystick using this analog read 2 and analog read 3. And then this is the code that checks to see if anything has changed enough that we should update and print those to the screen REPL down here, which I'll launch in a second. And then buttons are equal to this button mask message that says, all right, here's the state of all the buttons. So we just get dumped that message every cycle of the program, and it tells us what's happening with the buttons. If something's happening, most of them we're just printing A and Y and the select button. But if we press B, then I change that frame variable to be incremented. I add 1 to it, and I use the modulo function to loop through the list back to the beginning when we go forward more than the length of that file or that list. And the X button does the decrement, so it does a -1 in the same modulo. So if I go ahead and open up the serial output here, if I move the thumbstick there, you'll see my values. They sit around 512 and 512 in the middle. Not exactly that. Almost 0 to the left, almost 1024 or 1023 to the right. Up is, I think, 1023, and down should be close to 0. So that's how we can use, we can read those and print what's happening on them. If I press a button, we'll see that show up in this screen. Again, this is real slow right now just because of the inefficient code that I have that's constantly trying to redisplay the image, so we're always waiting on that. But you can see, if you watch my little screen here, when I do press the A button, I will update. And actually, if I hold that, it'll try to animate it pretty much as fast as it can. Uh-oh. Oh, do I have some of my code goofy there? I didn't think I could go out of range. Maybe I have to subtract 1 from that list. Let's rerun this. That might need to be -1, right? The length -1, probably. All right, I don't think I tried going that far. So there's, what do I have? 6, no, I have 8. So we'll try pressing this 8 times and see what happens. So 1, whoops, what happened? I can't put that there, can I? Let's put some parentheses around things. And where's the other one? That should be better. Okay, 1, 2, 3, 4, 5, 6, 7. Oh, I went out of range again. All right, I have to play with that, and I'll make this run a little better so that I don't have to wait so long to see it change. Is there? No, I don't know why it's doing that. I bet there's some tips in the chat though. If anyone sees what the obvious issue is in me trying to run through that list, let me know and we can try it. Yeah, parentheses of the program is trying, except I've still screwed this up. No, I do want it to be modulo of the list length, right? Yeah, this is okay. I don't know, I'll throw in some more proper looking parentheses. And what I'm going to do actually is not update the screen, and I will just print frame. So that I can see what's happening. All right, 1, 2, 3, 4, 5, 6, 7, 8, or 0. Yeah, 1, 2, 3, 4, 5, 6, 7. All right, that looks proper. So did one of those images not exist on disk? Pip 1, 3, 5, 7, 9, 11, 13, and 15. Let me just check that I actually copied all those over, but I don't think that would have given me that error. 1, 3, 5, 7, 9, 11, 13, 15. No, that's all fine. Okay. I should do x plus 1, and then David G is saying I should do x plus 1. Modulo something. You were doing x plus 1 modulo something. Okay. Yeah, so I did put those in the parentheses now. And I don't know why that didn't work. Well, the numbers are behaving, so let's see what happens if I do show my image again. And you know what? While I'm at it, let's see if I can make this a little better. So let's do last frame equals, we'll make this equal, originally it's just the length of the file names. Oh no, actually we'll make it 0 to start with, right? Let's try that. So if frame is last frame, oops, not that, indent. So let's see, that means when I press the button, I'll need to increment last frame. So we should only draw it when that's true, right? Frame is the same as last frame. It'll draw until I update it. I see that I have a flaw in here, but let's see if I can make that work. So last frame, last frame. Oh wait, no, this is not going to work. All right, let me bail on that. We'll just put up with the slow display. Sorry. I got a little ambitious there. Oops. All right, so let's see if that works. It's doing the modulo before the plus is what people are saying to me. Okay, so is this still doing that? Hey, at least we got the print of the numbers now. 2, 3, 4, 5, 6, 7. Here comes 8. Okay. Oh, it does work now. Okay. Thank you, everyone, about order of operations. I think that is what fixed it. Let's see if we can go backwards. 4, 3, 2, 1. Yay! Okay. So now it's doing the modulo before plus, or it was. Okay. All right. So let's see. What I wanted to do. You know what? We're just about out of time because I had the problems with at the top of the show. Rather than go long, because all I want to do next actually is improve that wiring. And let me jump to the bench cam here. I'm not going to improve the wiring right now, but I am going to do the wrist strap so you can see how that's going to work, and I can put the battery in there. So let me put in a corner camera there. Okay. By the way, my important notes when I was trying to actually get my wiring right was this little thing, including colored wiring. I know I don't always use like rainbow wiring, but in this case it was really helpful to say, okay, since I'm sort of translating from, get that in focus, since I'm having to translate from this row of pins that I'm not using every single row in. So we start with 3 volt, then we skip, then we go to ground, and then we use the remainder until the last 2, which are empty. I had problems. I started at the bottom and screwed everything up last night. And since we're going from this kind of single row to these sum pins in 2 rows, it was helpful for me to write that down, use those color pins, do it on a breadboard first, now have it this way. So then that next step is going to be to say, okay, very carefully make sure that I'm heading into the right short little runs of wiring on here, and then I can get rid of all this stuff. So that was part of the process for me there, is to just have a guide. This won't work very well as a wristwatch right now because of these pins. I'm gonna leave them in though for now, but I will show you how the strap can work here. We should have the space under here to put that there and there. Same with down below. You know I love zip ties. This process is good for kind of the bare bones version. If I end up making a 3D printed case for this, I will probably not be using the zip tie method anymore. I'll probably use some screws. I use these M25 screws and standoffs and fasteners and nuts. But for now, simply go like that. Run the strap through. Oh, I put that one twice in the wrong. Just to move over. There we go. That gives us enough space. Just this is a wide wrist strap. And then we can pull that tight through there. You can also use the dual if you want to. Do you know this trick? If you don't want extra zip tie here, you can take a donor zip tie. Let me grab a couple more. I'm going to grab some blue and a purple one just so you can see this a little better. This is one of the great things about zip ties. So let's say we couldn't run that there or we just don't want to, we can simply turn this into a zip tie fastener. So what I'll do is take some diagonal cutters or scissors and snip the end off of a donor. And that's your fastener. Boop. Get rid of this. Don't cut any wires. And now we have a neato zip tie that didn't have to run across the middle there, which is a bit excessive. I don't really need anything there. Again. And that is reason 700 of why I love zip ties. Okay, so again, like I said, this is not going to be super comfortable right now because of these spiky things. In fact, it probably won't really go around my wrist, but I can give it the old college try. It's just at a jaunty angle. Okay. So as long as you don't have the benefit of perspective where you can see how that won't be flat until I get rid of those header pins, get an idea of what it'll look like on the wrist. And why don't we finish the demo here by popping in the little battery. And like I said, these charge. It's one of the great things about the Feather is that charging built in. So no added charger, just plug it in and off it goes. Now again, with a 3D printed case, I'll probably have a little nicer home for the battery, or you could just use some foam core, not foam core, foam tape. And did I break something already? It's trying. Let's restart it. There we go. Beep, 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 beep. Go in here. Our next map or whatever screen. And that is it. That is the PipBoy 2040 right there. Huh? Another nice thing to do if you're going to go with sort of a bare bones version of this is to put something like a little fabric or foam or leather or something underneath there because you don't want to be shorting things with your conductive human flesh and sweat. I got a question over in YouTube. It's Sherry M6S191 DRML who says, I apologize, I just arrived here. What is that exactly he's making? So this is a miniaturized version of the classic. Oh, I have green screen. This is green screen turned on by accident, so it's punching it out. Turn that off. Of the sort of classic PipBoy from the video games Fallout, which is like a big honking screen on your wrist with some controls. And so this is a sort of modernized, simplified version that doesn't use a Raspberry Pi, but it's still programmable, unlike the iPhone one. That, by the way, is one cool thing about some of the... There have been official PipBoys licensed and sold in various ways. There's even a deluxe version of the game that came with it. And those usually take an iPhone. That's why that iPhone app works. So you just pop in a disused phone. I don't know what models it fits. And then you have a ready-made thing. You don't have to use a Raspberry Pi. But you can't do as much with it. You can't customize it. I'm not that familiar with what the state-of-the-art is of the Raspberry Pi-based PipBoys, but it's open source, huge scene with people doing cool stuff for it, making functional radios and media players and GPS tracking, mapping, and all that. So I'm not trying to do that. I'm just trying to make a thing that looks kind of cool on your wrist. And so that's my project for today, and I'll be working on turning that into a learn guide so that you can make your own. And that's using our little round rectangle display, SPI display, the Joy Featherwing, and in this case I've got the Feather RP2040 inside of there. And of course the Feather Tripler that makes it all possible. So yeah, PipBoy JP2040. Thanks everyone for sticking through it. Sorry about the weird software issues I had earlier on in the show. It seems like it's streaming decently now. If we head over to the Discord, Funkfinger just showed a PipBoy watch on the Watchy. That is cool. Is that an e-ink display? I love the look of that. And that's a real watch. If people are motivated, it would be great. I'm going to release this project just as this sort of simple kind of slideshow type of thing where you can press buttons and get different screens. But I'd love it if people extended this and wrote involved, interesting code for it. So we'll see where this can go. You could also do, if we get the image load thing that I had not working going with the Feather Sense or the NRF52840, you could do some Bluetooth stuff, including sending images from your phone to the display. So there you go. All right, well, thanks everyone. Thanks for stopping by, and I'm going to take off. I will see you next week for another round of shows, including, let's see, I'll have a product pick on Tuesday. I will be hosting the show and tell on Wednesday evening, so come by for that. There should be a 3D Hangouts Wednesday morning, and there will be an Ask an Engineer after the show and tell with Lady Ada and Mr. Lady Ada. And then Thursday, I'll be doing another John Parks workshop. Maybe I'll have designed and 3D printed a case for this that we can start to explore. What else? Scott is having a deep dive, I think, tomorrow. And then he'll be having one next Friday as well. I forgot to mention that first. Let's see. We have this live broadcast announce chat. This should tell you when things go live. So this is one place to check. It says that we're live right now. And you can also do the showtimes command in the Discord, and that'll tell you that Scott's deep dive, 5 o'clock Eastern time on Fridays. So that should be happening tomorrow. As Scott continues to battle with USB on the bare metal Raspberry Pi Circuit Python implementation he's doing. I think that's what's up next. So really exciting. All right, thanks everyone. And if you can please send us your votes of if you want me to send this doorbell to C. Grover, or if you want C. Grover to send me his transformer, let me know, because we deserve to have these two come together and make some doorbelling sounds. And then maybe we can make it internet connected. Someone asked for a link to the Discord. You can just go to adafru.it/discord. I'm not sure if I can share how you share that out of here. Let's see. Can I right click on something? Invite people? What does that do? I don't know. But if you go to Adafruit's adafru.it, adafru.it/Discord, you'll get an instant invite. And that was a question from the Backwoods Engineer over in YouTube. All right. Pony Lover says they're a huge Fallout fan. Very cool. I really need to play Fallout New Vegas. That's the one that I keep hearing I should play. All right. Thanks, everyone. I'll see you next time. Bye-bye.